Thank you. So yes, you're gonna see a video that's gonna explain better than many thousand words what we did. But I just want to start giving you some initial information, some story in the story. So what you will see, again, 800 lines, 3 semi-submersible barge used to move and launch a over 23,000 metric ton vessel. Just to materialize, it's about 140 million euros of equipment, moving about 600 million euros of cargo. This is what we do, what everybody in the industry does. We make difficult operation look very easy. So you'll see in the video something that developed, in a day of work, but it took years of preparation, and the preparation was really the key. So, talking SPMTs, we touched different topics today, not the SPMT, so I'm the first one talking about that. I first got to know the SPMT in 1993 when we bought the first batch. Before that time, I wasn't in the heavy lifting or heavy transportation, I was in aerospace industry, I'm an aerospace engineer. So what I was doing, rocket science, that's exactly what it was. But getting to the SPMT was initially, those machines, they can do many different things, a lot of things besides flying. But they're complicated. So that's the first lesson you learn. So when you see 880 lines getting together, for people that have been operating this equipment, think about having 880 lines of 3 different generations, 3 different capacity per axle, 36, 40, 48 metric tons, operated by a single remote control. That was a huge achievement. Even Scheuer couldn't believe we could do that, but we did. The rest is, of course, what I said, the story in the stories. It's a preparation. It's been years of work. We started with a concept. The ship was built on the dock, and the limitation is always what you have not only on top, but what you have beneath. So, ground bearing pressure. So the ship changed weight, as typically can't do all of that, size does. So we had continuous challenges. And the initial work was engineering the transport configuration under the ship. And so that was quite intensive work. But I may say the most challenging was outsourcing all the equipment. We have 880 lines. In the group, we have about 2,000 altogether. 880 is about a little bit over the fleet that we currently operate in the States. And we had to find also 3 semi-submersible barges of sufficient dimension to allow the load out. One of these is the largest ever built, and it came from China, and that was the initial, the inaugural job. But to get more in detail in the story, this project was a moving target for us. So the customer gave us an initial date, as per contract, and moved that date 3 times. So the work that took place in April 2024 was initially foreseen for a year and a half before. And so keeping all the equipment available, keeping the barges available for the job was a big real challenge. But now again, enough words, let me show you the video, which is gonna, better than anything else.
About yourself a second.
We don't have a video. Do you have a video? No, you have a memory stick. SPMT ship memory stick. That's part of 88,000 lines that we have on the job. Yeah. Anyway, that's fine. Yeah, well, the video is what was awarded by the SC&RA as Job of the Year for 2024. And again, you'll see there, job executed in half a day, 12 hours, but the preparation for the job was years. And so getting 880 lines, keeping them available for the customer that kept shifting dates was a real challenge. Technically, if you want to, it's probably not that difficult. It's putting a lot of equipment on the big vessel, making sure that everything fits. But again, the challenges were really logistics, organizational, and I may say for the people operating the SPMT, which by the way also had 2 female operators, which is important to say, out of a group of about 25, was a real challenge. Putting together 880 lines and making them work as a single trailer, that was a big challenge. I hope the video is ready. You ready? Okay, then please launch the video. Oh, okay. So I can finish with another, the biggest achievement was really keeping the client after all this. Of course, clients are very sensitive to the money. So I cannot, of course, keeping all the equipment available costs money, no matter what, we could do. But we try to be creative, saving money to the customer, using the equipment on the project, trying to be flexible, waiting the last call, which came only 3 months before the job. And so the biggest achievement was really keeping the customer after the work, because that was something I feared it could break as a relationship, because there were so many changes that were really not easy to control. Ready? Okay, please.
Yeah. Everybody
established a national offshore wind energy target for the installation of 30 gigawatts by 2030. This ambitious goal was intended to not only help reduce dependency on fossil fuels, but also establish a new and sustainable renewable energy industry in the United States. Citrium's Amfell shipyard has partnered with Dominion Energy in this groundbreaking project to supply the Charybdis, the first of its kind U.S. Jones Act compliant wind turbine installation vessel. Charybdis is the name of one of the Greek sea monsters who made it difficult for Odysseus to complete his epic journey in the Odyssey. Charybdis's first job will be to install the turbines on Dominion's 2.6 gigawatt coastal Virginia offshore wind project in federal waters off Virginia Beach. The B212-Charybdis will have a maximum lifting capacity of 5 million pounds, or 2,200 metric tons, and be able to lift to heights of approximately 600 feet, or 175 meters above sea level. The vessel is designed to handle turbine sizes of 12 megawatts or larger. Hull, length 472 feet, width 184 feet, depth of 38 feet. Weight, 23,162 metric tons, 51 to 63,470 pounds. Combined loadout weight, 26,892 metric tons, 59,286,712 pounds. The vessel was built onshore at the Citrium Amfell shipyard in Brownsville, Texas, and Fagioli was challenged with the major logistic and engineering task of moving the vessel to the water. Fagioli moved several vessels at the shipyard, weighing up to 10,000 metric tons, and was initially requested to study the move of a vessel weighing twice as much. A skid loadout was considered, but ultimately not feasible because of the limitations of the dock's capacity and the inability to upgrade it. The move and loadout operation was finalized with the use of 880 axles of self-propelled modular transporters, SPMTs, 28 power pack units, and 3 semi-submersible barges. By Fagioli involved contracting and coordination of multiple international entities. Time constraints were also a factor. factor as the loadout was executed within Port of Brownsville waterways, as the port had to be closed. The planning, detailed engineering, subcontracting, and preparation took over 2,000 man-hours. The loading dock, with its 2,000 pounds per square foot maximum allowable bearing pressure and 9 height above the water, combined with the enormous weight of 60 million pounds of the vessel and the location of the center of gravity, were taken into consideration when determining the equipment needed to safely complete the project. The result was the use of 880 axle lines of SPMT in 3 groups and the resulting need for 3 barges with enough buoyancy and internal ballast system, none of which exist or is in service in the United States. After an intensive search, Fagioli contracted BOA out of Norway for 3 semi-submersible barges to be used as dock extensions. The central barge, measuring 500 feet by 125 feet by 30 feet, with uniform deck strength of 7,200 pounds per square foot, an internal ballast system delivering 7,100 cubic feet per minute, is among the top 5 largest barges existing in the world. The 2 side sister barges, each measuring 407 feet by 105 feet by 26 feet, with uniform deck strength of 6,500 pounds per square foot and internal ballast capable of 3,600 cubic feet per minute, completed the equipment list. Barges had to come from Asia and Europe. Despite their molded height and buoyancy, each barge required a layer of crane mats on their deck to manage the dock height and ship's weight and maintain the barge's level with the quay during the full tidal cycle. The ro-ro ramps had to bridge the gap between the barges and the dock, with an additional 12-foot distance from the face of the jetty. System redundancy means that adequate backup systems shall be provided such that the loadout can still proceed in the event of failure of any one mechanical component, hydraulic system, control system, or power source. Communication plan was key for the safe execution of the work. Simultaneous loadout on 3 different barges, each with independent ballast system, complex and redundant mooring system. 5 tug push boats, 8 mooring winches, and multiple lines. Specific training for key personnel, matrix of responsibilities, a communication procedure for transport, tug barge implementation of 72 hours outlook, weather forecasting, operations, go, no-go checklists, equipment failure, contingency plans, HSE procedures, SHS plan, environmental plan, regulatory plan. Fagioli was officially awarded in June 2022. The Charybdis was the first of its kind, and the shipyard encountered supply chain slowdowns and labor challenges that delayed the loadout twice. Successful execution of the loadout in April of 2024. The 880 axle lines of SPMTs were divided in 3 groups. The central group with 480 axle lines was 150 feet and 115 feet away from the 2 side groups with 200 axle lines each. The electronic communication among the 880 axle lines and 28 power pack units presented an enormous challenge. Each 4 and 6 axles unit had to be vetted and tested to ensure compatibility. There are several generations of equipment each with a set of different challenges to overcome. Multiple signal amplifier have been added to the data lines. Long hydraulic hoses for a 3-point support configuration connected 2 of the 3 groups. The result was all 880 axles communicating to a single control box. The transport system was redundant, as adequate backup systems were provided such that the loadout could still proceed in the event of failure of any one mechanical component, hydraulic system, control system, or power source. The provision of 880 axle lines and 28 power pack units needed for the project required advanced planning, and some of the equipment had to be transported from Europe and Asia. The barges were connected by spacer barges and kept in position during the maneuver by 8 winches and multiple mooring lines, as well as by 5 tug push boats, with 2 spare available throughout the operation. For the execution, Many factors had to be considered, including readiness of several parties, weather outlook, tidal projections, and port traffic. Multiple entities and governing bodies were involved in the decision-making, and the loadout date moved several times, adding the complication to keep available the 3 unique barges and 880 axle lines. Once the Charybdis was finally ready to be moved, she was about 1,500 tons heavier, reducing the margin, but still within capacity of the equipment. This first phase of loadout was positing the SPMTs under the vessel and alignment with supports, followed by taking the load to confirm distribution, center of gravity, and equipment operation. The 3 hydraulic groups on the SPMT measured the same weight. Once all was confirmed on the land side and all stakeholders agreed to proceed, the 3 barges were aligned to the dock and the port closed to maritime traffic. Alignment of the barges required 20 hours, including mooring with Fagioli, 30-ton winches, positioning of the spacer barges, alignment with ramps, and final ballasting. Next, the WTIV was slowly moved over ramps from land to the barges with continuous checks of the weight distribution on the SPMT. The 3 ballast systems were operated to constantly keep the barges at the same height above the water, with the mooring system and the tugboats working to prevent any movement. Loading dock 9 feet above the water and the internal ballast pumps on the barges compensated the weight of the convoy as it was transferred from the dock onto the barges. Finally, once the vessel was in position on the barges, it lowered its jack-up legs into the water and began to remove load from the SPMTs while water was pumped into the barges. The whole procedure was quite challenging as the SPMTs were hydraulically and electronically connected, but spread over 3 separate barges with different load and buoyancy. All parties were in constant communication to ensure the safely execution of the maneuvers. Once the vessel was offloaded from the SPMT were moved back on land. Tugboats were added to move the barges and spacers to positions not blocking the port waterways. Execution was completed well within the 72 hours allowed by the port, and the navigational channel reopened soon after. Despite supply chain delays, the loadout was successfully completed in April 2024, a groundbreaking achievement in heavy transport. In the process, Fagioli set 3 world records for the largest number of axle lines under one load, the heaviest weight ever moved by SPMT axle lines, and the heaviest load on wheels transferred onto multiple barges.
I have one. Okay. How much of the SPMT was already in the US? How much did you have to bring from outside?
We have about 800 lines in the US, but working on different job sites. So we dedicated to this project about 500, and we had to bring about 350 from overseas.
And were they all yours? Or?
No 100 lines we went in the US from
Okay. Good. Why was the vessel 1,500 tons heavier by the time it came to the loadout?
Well, they kept adding weight. I mean, of course, they saw the capacity, they saw we could handle more, and they like to finish the vessel, I mean, on land rather than in sea. So, yeah, we kind of noticed that, but it wasn't explicitly said. So when we started picking up the weight and so we determined that it was heavy. She was heavy. But again, there was a certain caution that we built into designing the system, the moving system, the barges and everything else. We could take it on and move it
So it was all within capacity, you didn't have to add any others.
Yes, remember the low value capacity of the ground was limited, so you could use 36 tons or 60 tons, it doesn't matter. You just need to shape the footprint, so you need so many expertise. But again, we managed to keep some spare with that. Actual simulations. Plus the distribution of the weight and loading on 3 barges, there's always a little bit of uncertainty about what exactly the crews are like. So the moment is something else.
Okay. Anyone like to? Yes.
What is the most important lesson that you learned that you could have done better in this project?
It's a good question. I think we did everything that we were supposed to do. The most difficult situation to manage was the customer, the continuous delays, so to say, in the loadout, and in them understanding, what exactly the consequence was. So I may say maybe a better communication one at the beginning. Like again, what I said at the beginning, we look difficult operation, look easy. That is the eye of many customers. They think, what we do is okay, you have 2 lines and that's it. We take more time. What is the problem? That is the communication plan that we need probably to deliver better to the customer. That is operation, certain boundaries and moving the boundaries is going to be critical for everybody.
Okay.
Yeah.
Thanks very much, Edoardo.
Thank you.
Spectacular. Pleasure.